1 fits, curve fits basically. So here's where we left off before. I want to get rid of all this. I'm going to cheat. I'm going to, let's see, hold my mouse down, highlight maybe all 4 of these, right click. I love right click. Delete. Delete the columns. Boink. Ha, that took care of that. Okay, so I looked up some data and I want to enter some data here because you can't do a curve fit without data. So this would be, maybe I'll put a title here, Twin Cities Seasonal Snowfall. And of course it's in inches. And I think I will maybe, well, let's do this. We're going to have a year. They call it the lead year. So if they say 1900, what they mean is the winter of 1900 to 1901. So the lead year, and then I'll just put inches, I guess. Inches of snowfall, which means it's redundant to put inches here. So notice what I did is I clicked on this cell because that's where I entered the text. So clicking on this cell doesn't give me access. Click on this cell. Okay, now I got access. I can put this here and I can just kind of take out the inches. Boink. Okay, cool. Let's maybe do something like this. I could set the column width by coming over here and doing, where is it? Format, there it is. Format column width. Or I can cheat. I can just kind of come up here and kind of like maybe drag that over to here, and then maybe like drag that over to here, something like that. That's close enough. Let's do a merge cells here, which actually I don't need to right click. It's right here. Merge cells, boink. It's centered for me. That's nice. Bold, maybe yellow. And here. In fact, I want to center everything everywhere. So what I can do also is I can highlight up here the title A and B. So when I drag across the title A and B, notice it selects the whole darn column. And so I can go like this. I want you to center the whole darn column. Boink. I said center the whole darn column. Boink. That's better. So let's put like, maybe I'll make that yellow too. Maybe I'll put a border underneath it like that. Cool. Good enough. Okay, so we're going to type in some years. I went every 10 years from 1890 to 1900 to 1910 to 1920. And this is a good trick. If you've got a definite pattern like this, I hope this is going to work. What I did is I highlighted these 4, and now I'm going to drag down. Oh, what'd you do? And now I'm going to drag, see, I'm going to click on this little thing here. When it becomes a narrow crosshair, I hold and I drag down. Oh, I'm up to 2030. That's further than I needed to go. Okay, cool. So there's my years. I love that. That's great. It's like autofill. Those are the years. Now I had to type this in, or we have to type this in manually. So 33 inches, and I'm going to hit the down arrow. And then 42 inches, and then we had 37 inches. Life is normal, life is good. 21 inches, a little low that year. 14 inches, uh-oh. 53 inches, yay. That's called regression to the norm, I think, where the snowfall was getting low, so to even it out, it kind of comes out high, and it's not guaranteed. Nothing's guaranteed in physics. 89, boy, that's a whopper. Okay, 40, down to 40. 55, down to 21. Uh-oh. 44, 75. Woohoo. 85. Yay, good year for snow. 47. Okay. So we got some numbers to play with. Cool. Now, if we were hoping that this was linear, and I don't know that it is, I just grabbed some numbers, but if we were hoping that this was linear, we could find the equation of the line, and we could do that in a couple, 3 steps here. So first, I'm down in this cell. I'm going to say M equals, and I'm just going to leave that there. B equals, and I'm just going to leave that there. So coming over to M, how do I do M? Let's go up to formulas, and I have to come way over here to where it says more functions statistical, and I'm just dragging my mouse here, right? Or, dragging it along, and I want to get the slope. So you're looking for slope. It's got to have a slope. Come on, have a slope. Slope. Boing. And I love this because it tells you what to do. Highlight the known y values. So I'm going to use inches as, pardon me, y values. So while my cursor is blinking here, I come up here, press hold, drag down to here, release. Those are where my Y values are stored. Click in this cell. Now it's blinking here. Here's my X values. Click hold, bring it on down, boink. Insert please, boink. And there's the value of the slope. It's got a slope of 0.25. It's a positive slope. What's that telling you? It's telling you that the amount of snowfall has been going up an average of 1/4 inch per year over this past, how many years, 100-something years. Let's see what we got for an intercept. So again, you put I want the intercept number to go here. So I make sure I highlight that cell. I come over here and I say, okay, where is that? More function, statistical, and it's not called y-intercept, it's just called intercept. There it is, intercept, boink. And the known y's, okay, we're back in familiar territory. Whoops, not that. The known x's, I click here, and then I highlight all those. Boom, it's got a y-intercept. Really? A y-intercept of negative 447. Well, what does that mean? It means if you go all the way back to the year zero, then theoretically we had not a lot of snow in year 0. It was negative. I wonder when it becomes positive. I don't know. But that would be the equation of the line. Now, is it a good fit or not? There's a question. So you remember that R, the Pearson product moment coefficient correlation thingy? We're going to get the R. It was called the Pearson product moment correlation thingy wingy. So I'm highlighting this cell. Let's come back over to our more function statistical Pearson. So I'm looking for Pearson. Pearson. Now it says independent values. That would be your X's. Okay, so X's are from here to here. Click here. Now put the dependents. That's the Y values. Put the Y values here. And by the way, I don't think it makes a difference. I think the R comes out the same if you swap those. But anyway, insert. Boink. So it's got an R of 0.458547421 or thereabouts. By the way, if you don't like that many decimal places, here's something you can do. Let's see. I think I'm going to do right click. Was this going to work? Come on. Come on. Format cells maybe? What is this now? Not format cells. What am I going to do? I'm going to format the data. I've seen this somewhere. Let's go to home page. There's got to be a way. Oh, it's right here on top. I'm looking all down here going, where the heck is it? It's up here. Okay, so where am I? I'm on the home page. I come over here to the ... more options, and you can increase the decimal or you can decrease the decimal. I'm going to decrease the decimal once. What, I have to hit this again? Are you kidding me? You're going to make me do that again? Is it here? Oh, I can set it right here. I can say I want, I don't know, 3 decimal places. Boom. That's better. Okay, so 0.459. By the way, question, is this significant? You have to look it up on the table that I provided you in class. Now we'll use a level at 0.05 level. We've got, how many data points have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We've got 14 data points. And then I've got a table right over here handy, in fact. So for 14 data points at the 0.05 level, we would need, it turns out, a 0.532. Guess what? We did not meet the threshold. A line is lousy. That's one way you might say it. Or if you want to be official about it, there is no statistically significant linear correlation. Which is good, because who wants to have a y-intercept of negative 447? Not me. So it turns out, okay, I was thinking maybe, the snow we're getting is going up or down because of global warming or whatever. It turns out, no, there is not any statistically significant correlation. Okay. Well, anyway, that's one way you could get the equation of the line. So what is the equation of the line? So it would be y equals m is 0.253, maybe I'll call it x, plus and then the, or not plus, minus the 447.26. I like to 264, I guess. I like to use the same number of decimal places, but that's our equation, but it's not really a linear correlate. It's not a statistically significant, which means if we graph it, it's probably going to look like a big scatter cloud. It's not going to look like it's all going up. So, okay, now I want to show you how to get the graph of this stuff. Thank you. Because what I was supposed to do is I was supposed to do this, and I suppose I could grab the titles of the columns too. Maybe, I wonder what would happen if I grabbed all of this. Let's find out. So I grab all of that, so I guess that's what I have to grab is all of that. And now I insert the scatter chart. There we go. Now I can just drag it where I want it. So I'll drag it over to here. Yeah, I don't know. It looks like it almost has a straight line to it. So that's inches going this way. I don't know why it didn't label the y-axis. And I'm going to click on this, double click, I guess. Try to double click. Well, it used to be you get the cursor in there and you could do it. But I guess what you have to do is you have to come over here now. So when I click this, up comes the chart formatting options for the chart title. And I can say seasonal snowfall. Well, I guess let's put Twin Cities. Seasonal snowfall in the Twin Cities. So you can do all kinds of things. So we got the graph there, and I don't know. I'm wondering if a line would kind of work. So anyway, I'm gonna, in order to get a line, here's what you can do. Grab one of these data points, right? Right-click on the data point. And when you right-click the data point, yeah, you can format and stuff, but here's what I'm interested in. Add a trend line. Boom! Oh, look at that. See, it does seem to be a straight line there. It's not statistically significant, apparently, but it's close, I guess. So there's our trend line. Now I'm going to, let's see. Does this have our trend line over here? It just says turn on the trend line. I guess I could have done it that way. Anyway, I'm going to right-click the trend line. Add trend line equation. Boom! And that's way too small for you, so I'm going to click on that. Is there a way to change the font size right here? Sure. Who wants 9? I don't want 9. I want 12. That's better. I'm going to drag it somewhere where I can see it, maybe here or something. Boom. Okay, so what are we looking at? There's the equation. Now, by the way, does that look familiar? 0.2527x. Uh-huh. Minus 447.26. Uh-huh. So there's another way to get the equation of the line is you can go through the rigmarole of making a plot and adding the trend line and adding the trend line equation. It's the same darn thing. Be nice if we had the R, wouldn't it? So we've got the R of 0.459. Okay, that's nice. I'm going to click on that equation again. You got an option here. It says display. Now it says capital R squared. Well, let's see what capital R squared is. It's 0.2103. Well, what's that then? Well, watch this. Maybe I'll just put a note down here, and maybe I'll put it in a weird color because it's a weird note. This is a weird note. So I'm going to say, okay, PS R equals 0.459. That's what we came from with the Pearson. That would be the Pearson. Notice that R squared is, and I'm actually going to literally take the 0.459 and square it. 0.459 squared comes out to 0.211 roughly. And look what they got. Well, it's close anyway. I guess I did round a little bit, but anyway, 0.210. Basically, this capital R and this little r are almost the same thing. So if you have the capital R, maybe I'll put it down here. R squared is 0.2103. And so if you take the square root of that, R equals, let's see, square root, 0.2130. 03. It's supposed to be 03. I'll type it in that way. 0.2103 square root, boom, is about 0.459. So yeah, not that. It's supposed to be 03. Okay, so 0.459, 0.459. See what I mean? So you can actually, if you want to get at the R, and if you want to determine by looking up at a table, is this a statistically significant linear fit correlation? That's what you would do. You would take the square root of, now why they use R squared, I'm not sure. I don't know why capital R is different from small r. Maybe somebody has a new and improved correlation coefficient. I don't know, and it comes out the same pretty much. When they tell you the R squared, you can take the square root of it and say, oh, that's the R then. So the R is 0.459. And then you can look up the little r on a table and say, for so many data points at this significance level, like I did over here, it turned out we needed 0.532. We didn't quite make it. They didn't really make it, so it's not quite not at the 0.05 level. Maybe at the 0.10 level. I don't have a table for that, unfortunately. But it might be at the 10% level or something like that, just not the 5% level. Was I going to add something? Oh, yes, I wanted to add one more thing. This is cool, too. So you see that trend line. I'm going to click on the trend line again to get my trend line options. Just click on the trend line. Click on the trend line. Double click on the trend line. Chart. There it is. I had to double click on the trend line. So I double click on the trend line. See, now I get options. Trend type. I could choose other things like exponential, logarithmic, moving average, polynomial. Polynomial is probably the main one, because if you go to polynomial and you call order 2, that means x is squared. Order 3 would be you've got an x cubed term and so on. So I put a square, a parabola basically, in a degree 2, order 2 polynomial is a parabola. And where's the equation? Show the equation. Oh, for heaven's sakes. I guess I have to click on that one separately and add trendline equation. Okay, so 0.0004 x squared plus, minus this times x. So it's a parabola type thing. Can I get where am I getting? Oh, and then right here, display the R squared value. 0.211, 0.210, 0.211. It looks like the parabola might be squitch better than the straight line. So anyway, this is the kind of thing you can do too. Sometimes the data might actually fit a parabola much better, and it'd be good to know that. Okay, I think I'm done. Let me look at my answer key over here. Yeah, that's pretty cool. So what do? We had some data. We manually did the M equation and the B equation and the R equation to say, oh, this is the equation of the line, and turns out it was not a statistical linear fit, not at the 0.05 level. But hopefully, you might get one now and then and say, hey, it's statistically significant, cool. We kind of saw how to insert the chart, how to get your trend line, and how to get your trend line equation, and how to set the trend line to a parabola and get that equation and get that R squared. And remember, R squared is really the same as little r squared. Why they square it, I have no clue, but whatever. Wow, that was quicker than I thought. Okay, cool. How do you stop this thing?